Hello, this is Mr. Bissonette with another episode of Math in the Classroom. We started off the other day with our class. We were working towards this learning target of being able to move a quadratic equation that is in standard form into vertex form. And when we were working through that, I realized that some of the students, that it was getting to be kind of a lot all at once. So we broke it down into a couple different steps. So when we were working through it, the next smaller learning target that we realized we needed to work on was multiplying our binomials in perfect squares. So today we're going to go with I can multiply perfect square binomials. Okay, so this one looks like it sounds, there's some big words, and I think once we take a look at that, it should kind of get rid of that. And once you see the example, we should be pretty good to go. But to start off with, binomials, all this means is bi is going to be our bicycle. It's going to be 2. And nomials just means terms in math. So we have something that has 2 terms, and it's going to be a perfect square. So what it's going to look like is if we have f of x equals something like x plus 5 squared. Being able to expand this. So the first thing we have to realize is, what does x plus 5 squared mean? Well, if we were to simplify it, 5 squared, what does that mean? It means 5 times 5. X plus 5 squared, what does that mean? It means x plus 5 times x plus 5. Once we see it like this, then it's right back to just multiplying binomials together or expanding binomials, and it should be fairly familiar. But taking that step to get there, once you make sense of it, I think you should have it. Now, one of the things that I've heard students say when they're trying to explain this back to me is it's x plus 5 2 times. And I took a brief moment to kind of pause and slow down with our class and really be specific about that. Because technically, x plus 5 2 times, or 2 times, however, which way you want to look at it, would actually be that. And mathematically, that wouldn't necessarily be a correct statement. So this is one of those ones that I'm real picky with students. When I ask what x plus 5 squared means, I make them say it out all the way. It means x plus 5 times x plus 5, or the quantity x plus 5 times the quantity x plus 5. Now, some people, when they're working on multiplying these binomials, they go through the FOIL method. Again, it's kind of nice to kind of help students get started, but it's not my favorite because it falls short once we get into trinomials and stuff that's bigger like that. So a lot of times I'll just explain it like we're going through the distributive property. The only difference is we now have multiple terms in there. So what that means is this term, it's going to multiply that term, and then it's going to go and multiply the other term. Okay, so we're doing multiplication. We know that because when we have 2 parentheses together, that means multiplication. And then once we accomplish that for this term, then we have to go and do the same for the other term. So here we go. X times x, that is going to be x squared. Now again, I have to take a little pause with this one. Students get this confused, and I think a big part of it that we miss it as teachers and as math teachers is these are the ones that we got to teach side by side. For example, x times x equals x squared. A lot of times students will try to say it's 2x, and I think it's really important for them to see that that is with addition, and that is where we get the 2x. This is a common mistake that I see with a lot of high school math students, and I think it's the best way to break it down and explain it and to show them is just to have those two examples right next to each other. All right, now we have x times 5. Well, we don't know what x is, so we can't really simplify it any further than 5 times x. Now, notice we have a positive term and a positive term, so it's going to be a positive 5x. Once we have that down, we then move to the next term. And so we're going to have 5 times x, and just like we did last time, we're going to get a plus positive 5x. And to finish off, we're going to have 5 times 5, which is going to be a plus 25. When we combined our like terms, again, our like terms, same variable. These are the same variable, but it also has to be to the same power. So this is not a like term because they have different powers up here, but these are going to be like terms. And if I have 5x plus 5x, we're going to get 10x plus 25. And this is another one that students, they try to do something funky with the squared. They're not too sure with it. And a lot of times I'll just simplify it down to, hey, if you have 5 crayons and you're going to add 5 crayons, what are you going to end up with? You're going to end up with 10 crayons. I think putting some of that simpler vocabulary to it helps students conceptually make sense of it. Now, what this is going to do is going this direction with our perfect squares, we're going to start realizing that our perfect squares, the way that we can identify them is we're going to have a perfect square here, we're going to have a perfect square there, and then the square root of this and the square root of this. So we would have x and 5. If we multiply that together and then multiply that by 2, that is going to be that center term. Now, I think you can see what's happening here, and I think you can see what's happening there. Why the times 2? Well, notice before we simplified it, we have 2 of the same term. Okay, we get 2 of the same term there, so that's why we have that 5 times 2. So, building the perfect squares will hopefully help us identify them, which then hopefully we will move towards factoring by completing the square so that we can place that equation into vertex form. Here is multiplying perfect squares. Thank you again for watching.